Hello guys and welcome back to MathZone. In this video, we are going to learn about composite function and also we will do some past paper. So let's look at this example. If you still remember, we can imagine our function as like a number machine where we can put certain values. For example, we substitute x equals to 1, you'll get a specific output which is 1 minus 1, 0. You substitute x equals to 2, you will get 1 as the output. You substitute x equals to 3, and then you will get 2. You just subtract whatever input that you have with 1. But what if I have the second machine? Here I have gx equals to square root of x, and I want to use the output from the first machine as my input for my second machine. So I use this 0, 1, and 2, the output from first machine. We use it as the input. We put it to our second machine. So we will get another output, which is square root of 0, which is equals to 0, square root of 1, which is equals to 1, and square root of 2. This is a condition where we combine two functions together. So let's imagine these two functions as like two separate machines, but we combine it into one machine. This is our fx and this is our gx. So the first function is fx, so we put our input, which is the x values. We put it to fx and we process it, and then you will get the output, which is fx. Now this fx is the input for the second machine, which is gx. Pay attention that gx means that we substitute x to g. But now we use fx as my input. So instead of writing down gx, we write down g in the bracket fx. Means that this is our first input. We put it into f and you will get the output fx. The output fx, we put it to gx and you'll get the final output. So in this case, gfx is our composite function. So we can summarize a composite function is the combinations of two or more functions. So let's look at the symbol. The symbol is gfx, means first do f, then do g. We do it backwards, even though we write g first, but the first function is f because we do it backwards from the right to the left. So gfx means that we do f first and then g. So we can summarize gfx as g in the bracket fx. We find fx and then we put it to g. fgx do the opposite, means that we do g first then f. The symbol fgx equals to f in the bracket gx. Same as inverse function, we have condition for our gf to exist. So gf only exists if the range of f is contained within the domain of g. So this is supposed to be g. So gfx only exists if the range of f is contained within the domain g. So we can write down as range of f is a subset of domain g. So range of f is within the domain g. What does it mean by that? It means that, for example, before we use this example and we put x equals to 1, x equals to 2, x equals to 3 to our machine, and we will get 0, 1, and 2. And we put it into our second machine and we will get the output, which is 0, 1, and square root of 2. But what if I put x equals to 0? What happened? You will get the output is minus 1. No problem for the first machine. But there is a problem when you put it into the second machine, because if you put minus 1 to our second machine, you will get square root of negative 1, which is math error. That means even though it works in the first machine, but sometimes doesn't work for the second machine. Because the condition for GF to exist, if the range of F, okay, this is the range of F, is contained within the domain of G. What is the range of F? Well, we can put any value of F, of X, and then you will get any value of the numbers. So the range of F is F all numbers, all real numbers, or Fx real numbers. But there's a problem because the domain of G is X must be greater than equals to 0, because you cannot put negative value inside the square root, so your X must be bigger than or equals to 0. So as you can see, the range of F can be any number, but the domain of G limited only for a value bigger than equals to 0. So in general, GF not exist in general. But how to make it exist? You have to limit your domain of F. You have to limit your first input, because we know that we cannot have negative value as our input, means that we need to limit our range. So we limit our range, limit the range. This is the natural domain, can be any number, but only the number that is bigger than equals to 0 that can be put in our second machine. Means that the range that we have must be also same, y more than equals to 0, or less than that also works. But when we limit the range, means that we limit the domain as well from the first machine. Before, the domain of our F is any number, real numbers. But now we have to limit our domain because we limit our range. So how to make it y bigger than equals to 0? So we have to put any value as long as it is more than equals to 1, because Fx, because y is more than equals to 0 and our y is x minus 1. So x must be greater than equals to 1. So by limiting our domain, if we restrict or limit our domain, we can make GF exist. So this is our composite function. Okay guys, let's do some past paper. Let's look at this question. The function f is defined by fx equals to 2 minus 5 over x plus 2. And the function g is defined by gx equals to x plus 3. The question is, we want to find f gx. And we want to give our answer in the form ax plus b over cx plus d. So, let's look at the definition. F gx equals to f in the bracket gx. This is our definition. And we know that gx is x plus 3. So we replace our gx with x plus 3. Now we have f in the bracket x plus 3. Means that we substitute x plus 3 to our fx. Means that we replace x plus 3, we replace the x here. So we replace the x with x plus 3. So we have 2 minus 5 over x plus 2, but we replace x with x plus 3. So x plus 3 plus 2. So we will have 2 minus 5 over x plus 5. Because we want to give our answer in the form of this. So that means, so you can see, we have to make the denominator same. 2, we multiply by x plus 5 over x plus 5. So that both of the term has the same denominator. So we can simplify it. So we will have 2x plus 10, you expand over x plus 5 minus 5 over x plus 5. Now we have equal denominator here, same denominator. So that means we will get 2x plus 5 because 10 minus 5 here over x plus 5. So this is our answer. Let's do the second question. Here we have two function fx equals to 1 plus 2a over x minus a and gx equals to bx minus 2. Now we want to find the value of a and b if we know that f7 equals to 5 over 2 and gf5 equals to 4. So let's do it. We start from what we know. We have f7 equals to 5 over 2. f7 means we substitute 7 to our fx. So we have 1 plus 2a over 7 minus a equals to 5 over 2. From here, we can simplify. We minus 1 both sides. You will get 2a over 7 minus a equals to 3 over 2. And we can do cross multiply. We have 4a equals to 3 times 7 minus a. Here we have 21 minus 3a. So that means we add both sides by 3. You get 7a equals to 21. So a equals to 21 over 7, which is equals to 3. Yeah, we got the first value of a. Now, how to find the b? We use a second formation, which is gf5 equals to 4. So what does it mean by gf5? Means that g in the bracket f5 equals to 4. So we need to find f5 first because we know our fx equals to 1 plus 2a over x minus a, and we already find that a equals to 3, so we substitute a equals to 3, so our fx equals to 1 plus 2 times 3, 6 over x minus 3. So we find f5, substitute 5 to our function, 1 plus 6 over 5 minus 3. You will get 1 plus 6 over 2, which is equals to 4. And we substitute f5 equals to 4, so we get g in the bracket 4 because f5 equals to 4. Equals to 4 again. Now, g4 means that we substitute 4 to our gx. So we have bx minus 2. So we replace our x with 4. So we will get 4b minus 2 equals to 4. From here, we can simplify. 4b equals to 6. 4 equals to, b equals to 6 over 4 or equals to 3 over 2. Let's look at the third question. We have the function f is defined by fx equals to 2x squared plus 3 for x bigger than equals to 0. The first question, find and simplify an expression for f(x). This is interesting because we put fx inside itself. So f(x), it means that f in the bracket fx. And what is our fx? It's just 2x squared plus 3. So we substitute the 2x squared plus 3 to our fx again. Means that we replace x here with 2x squared plus 3. So 2x, we replace it with this square because we have square here plus 3. Now from here, we need to simplify. So that means we have 2 in the bracket 2x squared plus 3 times 2x squared plus 3 plus 3. We expand the two brackets first, so we get 2, another bracket because we want to multiply the result with 2. So we will get 4x squared and then plus 6x squared. Sorry, this one is supposed to be 4x4. And then we have plus 6x squared and we have plus 9. Close bracket, and we have the outsider plus 3. And then we multiply again, and we'll get, this one is 12x squared, yeah? So we will get 8x4 plus, this is 12 times 2, 24 x squared, and 2 times 9, which is 18, plus 3. So you will get plus 21. This is our answer. The second one, we need to solve the equation. We use that and we make it equals to 34x squared plus 19. So f(x) is the previous answer. Here is just a quadratic equations. So let's do it. So we minus both sides with 34x squared. So we will get 8x4 plus 24x squared minus 34x squared. And we have plus 21. And then we minus again both sides by 19. So we make it equals to 0. Because we want to solve the quadratic. So we have to put 0 on the right side. So we'll get 8x4. And then we have 24 minus 34 is minus 10x squared. 21 minus 19 is just plus 2 equals to 0. From here, as you can see, we can divide both sides by 2 to make it simple. So 4x4 minus 5x squared plus 1 equals to 0. Now from here, we can use substitution. So let, for example, y equals to x squared. So that means we have y squared equals to x4. So the key here is if you have x4 and x squared, you substitute for x squared. We make it into another variable. Let's make it y. So after that, we square it, becomes y squared equals to x4. So we get 4, x4 is equals to y squared minus 5y plus 1 equals to 0. Now from here, we just do the factorization. So we have 4y and y, and then we put plus 1 here means that minus 1 and minus 1. So you will get the first one is 4y minus 1 equals to 0, or y minus 1 equals to 0. From here, we get 4y equals to 1, y equals to 1 over 4. This one you will get y equals to 1. But we want to find x, not y. So we substitute back. Y becomes x. So y equals to x squared. Right? So x squared equals to 1 over 4. And x squared equals to 1. Now, from x squared to x, we need to square root, but don't forget to put plus minus. So you will get x equals to plus minus 1 over 2. This one you will get x equals to plus minus square root of 1, which is 1. But in the beginning, we already say that our x only positive means that we ignore the negative value. So the answer only x equals to half or x equals to 1. We ignore the negative because we limit our domain. X must be more than equals to 0. Okay, move on to the next question. We have fx equals to minus x over square root of 4 minus x squared, where x is in between minus 2 and 2. And we have the function g is defined by gx equals to 2x, for x is in between minus a to a, where a is a constant. The question is, state the maximum possible value of a for which fg can be formed. So, if we recall, there is a condition for fg only exists if the range of the first function, in this case the g is the first function, is contained within the domain of the second function, which is f. Now, we know that the domain of f is given. So this is a domain of f. X must be in between -2 and 2. And because we want to make it maximum possible value means that we take this as our range. So our range of g also must be the same, means that gx must be in between -2 and 2. And we know that gx is 2x, sorry. So you will get -2, 2x, 2. And then we just divide both sides by 2, and you will get x in between -1 and 1. Now it's similar. This is our domain of g. X is in between -a and a. X is in between -1 and 1. So we know that a equals to 1. So a equals to 1 from here. Now, assuming that fg can be formed, find and simplify an expression for fgx. So we just substitute, yeah. fgx means that f in the bracket gx, and then gx is 2x, so f in the bracket 2x, and then you will get, we substitute gx to our fx, so we replace our x over here with 2x, so you will get minus 2x over square root of 4 minus x squared, so 4 minus x squared. So we replace x with 2x. And then you will get minus 2x over square root of 4 minus 4x squared. Now from here, we can simplify our equation. You will get minus 2x over, we can take out the 4, square root of 4, 1 minus x squared. And we know that square root of 4 is 2, so you will get 2 times square root of 1 minus x squared. So we divide divide by 2, cancel. So we will have minus x over square root of 1 minus x squared. Let's solve for the next question. Here we have fx equals to x minus 2 squared minus 4 for x larger than equals to 2, and gx equals to ax plus 2 for x, all real numbers, where a is a constant. The first question is state the range of f. If you want to find the range of a quadratic function, fx is a quadratic, you need to find the vertex. And luckily, we already have the completed square form. So the vertex will be, you take this number but opposite, 2, comma, we take this number, minus 4. So the vertex is at 2, minus 4. And then to find the range, we can sketch the graph. So we can visualize the graph. And this is 2, this is minus 4, this is your vertex. And because your a is positive here, it's a number in front of x squared, is 1, right? So it's bigger than 0. So the graph will face up like this. But we just care about the value of x that is bigger than equals to 2. So starting from 2 and bigger than to the right. So we don't care about this, so we can eliminate this. Now, from here, you just need to write down the range. The range is the y value, starting from 4 and up. So y bigger than equals to minus 4. We put equal sign because x also has equal sign. Second question, we need to find f inverse x. So we have fx equals to x minus 2 squared minus 4. Now from here, we apply the step to find f inverse. So make fx equals to y. Interchange x and y. And then we solve for y. So we can add both sides by 4 to eliminate the minus 4 on the right. And then because we want maybe y on the left, so I just swap left hand side, right hand side. And then we have we want to find y, right? We want to solve for y. So that means y is inside the square, so we need to square root both sides to eliminate the square. But don't forget to put plus minus. So we have y equals to 2 plus minus square root of x plus 4. If you still remember, for f inverse x, you have to choose whether you take the positive sign or the negative sign. So how to choose that? Look at the domain of f. The domain of f is given the equation x larger than equals to 2. So the domain of f always equals to range of f inverse, but you just need to change x becomes y, so y greater than equals to 2. So that means because it is greater than 2, that means we take the positive because 2 plus a positive value, because square root always give us positive value, means that we take the positive. So we get f inverse x equals to 2 plus square root of x plus 4. The next question, we just need to solve for fx equals to gx. So fx is x minus 2 square minus 4 equals to, and the gx is ax plus 2, but we have the a here, so we just substitute. A is minus 5 over 3 x plus 2, and then we just need to solve for this equation. So we can expand this, becomes x squared minus 4x plus 4. Use the a minus b square formula, equals to a squared minus 2ab plus b squared. And then we have minus 4, the outsider here, equals to minus 5 over 3x plus 2. So you can see this is a quadratic equation, and if you want to solve for quadratic equation, you have to put 0 on the right side. So this one cancel. So x squared minus 4x plus 5 over 3x minus 2 equals to 0. From here, maybe you want to eliminate the denominator, so we multiply both sides by 3 because 3 is our denominator. So you will have 3x squared minus 12x plus 5x minus 6 equals to 0. From here, we simplify a little bit, so you will get minus 7x minus 6 equals to 0. From here, you can do any method that you want. You want to do factorization, quadratic formula, or completing a square, but the easiest one is factorization. So let's see here. 3x squared is 3x times x. Minus 6, maybe 2 times minus 3. And then we cross multiply. This is 2x. This is minus 9x. And then you add, you will get minus 7, which is correct. So that means our result here is 3x plus 2 times x minus 3 equals to 0. So that means your first x is 3x plus 2 equals to 0, or x minus 3 equals to 0. So from here, you will get 3x equals to negative 2, x equals to negative 2 over 3. And the second one is x equals to 3. But be careful, you have to pay attention to the question because we limit our x only bigger than equals to 2. So that means this one is not the solution, so this is the only solution that we have because it's greater than equals to 2. And last question, finally, the composite function. So, given instead that GGF inverse 12 equals to 62, find the possible value of A. Now we combine three functions, guys. G, G, and F inverse. So, because we already find F inverse, maybe I will write again F inverse X equals to this one. 2 plus square root of X plus 4. And we have the gx. It's in the equation. We cannot use minus 5 over 3 anymore because you want to find the 8 now. So ax plus 2. Okay, so if you have this GGF inverse 12, remember guys, you have to do it backwards. So you do from right to the left. So that means we solve for F inverse 12 first, because GGF inverse equals to GG in the bracket F inverse 12. And we know that F inverse is 2 plus square root of x plus 4, right? So we can find F inverse 12, just substitute the 12. And then you will get 2 plus square root of 16, which is 2 plus 4, which is 6. So GGF inverse is F inverse 12 is 6. Oh, and that equals to 62 here. And we have GG6, means that G in the bracket G6. Yeah, we do this for the second function. And what is G6? And we have Gx is ax plus 2. That means G6 is substitute 6 becomes 6a plus 2. So you will get G in the bracket G6 is 6a plus 2 equals to 62. And after that, you have G in the bracket 6a plus 2 equals to 62. So that means we substitute 6a plus 2, we put it to our x. Yeah, so we get ax. Now x we substitute 6a plus 2 from here. So it's like ax plus 2, but now we substitute x with this. Equals to 62. Now from here we can just solve it now. You will get 6a squared plus 2a plus 2 equals to 62. And you will have 6a squared plus 2a plus 2 minus 62 equals to 0. Now we have minus 60 equals to 0. Maybe we can solve. We can divide both sides by 2 to make it simple. So you will get 3a squared plus a minus 30 equals to 0. Now from here you can just do, once again, factorization. 3a squared is 3a times a. And then minus 30, maybe minus 10 times 3, maybe? Let's see. Oh, maybe this is plus, this is minus. Because multiply minus 9a, multiply 10a. And if you add, you must have a here. So you will get a. So that means you have two factor. The first one is 3a plus 10 times a minus 3 equals to 0. So from here we can solve for a. The first one, 3a plus 10 equals to 0. So a equals to minus 10 over 3. A minus 3 equals to 0. That means a equals to 3. So this is our final answer. Let's move on to the next question. Here we have another two functions, fx and gx. And we want to find fgx. So fgx equals to f in the bracket gx. So we substitute. Gx is 2x plus 1. And then we put our gx to fx. So that means we replace x in your fx with this thing. Substitute here. So you will get 2x plus 1 squared plus 3. And we don't need to simplify. The question just find an expression. So this is already done. Because it's only one mark, guys. The second one, we need to find an expression for fg inverse x and state the domain of fg inverse. So what does it mean by fg inverse? You just need to find, so fg inverse x is the inverse of your fgx. Yeah, so this is a symbol. So because we know that fg is 2x plus 1 square plus 3, we need to find the inverse of this function. So same step, make it equals to y. And then we solve, before that, we need to interchange x and y. And we solve for y. So we subtract both sides by 3. And then maybe we can change left hand side, right hand side. And after that, we want to eliminate the square here because we want to solve for y. So that means we take the square root both sides. But don't forget, you have to put plus minus square root of x minus 3. So from here, we have 2y equals to plus minus square root of x minus 3 minus 1. And then we divide by 2 both sides. So you will get y equals to this one divided by 2 becomes plus minus half square root of x minus 3 minus 1 over 2. And once again, you have to choose whether your inverse takes the positive or the negative. How do we know that? Once again, you have to use the domain of your original function. So what is the domain of f(g(x)? Let's think about it first. So if I have f(g(x) means that this is our gx. We use gx as the first machine, and then the second machine is the fx. Because we know that the gx is x bigger than minus half, and you put that into the first machine, you will get your output. But what is the output? So maybe I'll move it here first. We put any value bigger than minus half. So that means because our gx is 2x plus 1, so we need to find the range. So you just substitute 2 times minus half plus 1. So you will get minus 1 plus 1 equals to 0. And then if we keep increasing the value of x, this value will increase as well. So that means your range for this one will be y bigger than 0. And this will become the input for your fx. Fortunately, the domain are equal with the range. So all of this number can be put to this function and you will get the output. But what is the domain of f(g(x)? That's the question. Well, we initially put x bigger than minus half first. So this is the first input that we have. So the domain of f(g(x) will be x bigger than minus half. So the domain of f(g(x) is just the domain of gx, or the domain of the first function, as long as all of them works. And after that, the domain of f(g(x) will become the range of the inverse, which is f(g) inverse. So that will become y bigger than minus half. Means that we take the positive. Why? Because we know that square root always positive, times half is always positive, and the y, most of them are positive because it's bigger than minus half. So that means we have to put positive. So y, or f inverse, will become 1 over 2 square root of x minus 3 minus half. If we take negative value, negative half. So that will become less than half. So because we want the y bigger than half, or minus half, sorry. So minus half must be added by the positive value. So that is the result. And state the domain of f(g) inverse. Now, if you want to find the domain of f(g) inverse, you have to find the range of f(g), because range of f(g) equals to domain of f(g) inverse. But what is the range of f(g)? Range of f(g) is just the final output. But what is the input for the second function, this one, value bigger than 0, and it's allowed here. Why value bigger than 0? So that means we just need to find the range of this when the value, the domain is bigger than 0. So how to find that? Very simple. Because we know the vertex here, maybe I'll draw it here. The vertex for this one is 0 minus 3, because we compare like x minus h squared plus k, but we don't have h here, so it's 0, and then the k is just 3. And then we just draw the graph. 0, 3 is here. This is the graph facing upwards because the a value is positive. And then because we just care about the value bigger than 0, so we erase this. Bigger than means that goes to the right. So your range here is y bigger than 3. Not equals to, because we don't put equal sign here. So that means your final range here, the final output will be y bigger than 3, which is the range of your fg. So that means this is y bigger than 3. That means the domain will be x bigger than 3. The next question, we just need to solve for fg x minus 3 equals to g of x. Okay. So let's do it. So we have fgx from the previous answer, 2x plus 1 square plus 3. So 2x plus 1 square plus 3. This is our fgx. And then minus 3 from here equals to g of x. What is g of x? You substitute fx to gx. And what is fx? Fx is just x squared plus 3. So we solve for it. So this one cancel, 3 minus 3. So you will get 4x squared plus 4x plus 1 equals to gx. Gx is 2x plus 1. So let me write here, 2x plus 1 means that we replace x with this. So you will have 2 times x plus 3, or 2x plus 1. Then we just simplify for now. So that becomes 2x squared plus 6 plus 1. And then this one becomes plus 7. And then we want to solve for this quadratic equation, so we have to make one side 0. So you will get 4x squared minus 2x squared plus 4x plus 1 minus 7 equals to 0. Then we solve it. 2x squared plus 4x minus 6 equals to 0. We divide both sides by 2. You will get x squared plus 2x minus 3 equals to 0. And then it's just simple factorization, right? So you will have x plus 3, x minus 1. So we have to value for x equals to negative 3 or x equals to 1. But be careful, because we use fgx, right? Because we use fgx, and we know that the domain of fgx must be bigger than minus half. So fgx, the domain must be bigger than minus half. Is there any equal sign here? No, it's just bigger than. So that means we cannot take x equals to negative 3. So that means our answer only x equals to 1. So that is our answer. Let's solve the last question in this video. We have two functions, fx and gx, and we want to find fgx and the range of fg. So first thing first, first thing first, we write down fgx is equals to f in the bracket gx. And what is gx? Gx is just 4 plus x minus 1 over 2x squared. And this big guy, we substitute to our little x here on the f because we put it into our function f. So you will get half, amplitude x becomes this, minus 2 from here. And then we try to simplify, so we get 2 plus 1 over 2x minus 1 over 4x squared minus the outsider minus 2. So we cancel the 2, so we will get 1 over 2x minus 1 over 4x squared. So this is our f(gx). The second question, you need to find the range of fg. If you look at fg, this is quadratic function. So to find the range of a quadratic function, you need to find the vertex or the maximum or minimum point. So how to find that? Maybe I'll put x squared first. And to find the vertex of a quadratic function, you can do completed square. Yeah, completing the square. So we can take out the minus 1 over 4. And then we have x squared minus 2x. Because 1 over 2 divided by minus 1 over 4 is minus 2. And you can check whether your answer go back to the original form or not. And then we complete the square for this. We take the b, which is the minus 2, and then we divide by 2. You will get minus 1. So this equation will become minus 1 over 4. Put the square brackets, put the small brackets, and then put the x, put the value here, minus 1, and then we square it. And then we expand. We will get x squared minus 2x plus 1. So we have plus extra 1. We don't have plus 1 here. So that means we need to minus 1 here. So that means your function will become minus 1 over 4. We expand times the bracket. And then minus 1 over 4 times minus 1 become plus 1 over 4. From here will be easy, guys, because we already know the vertex. This is the formula ax minus h squared plus k. From here, we can know the vertex is h comma k, 1 and 1 over 4. So that will be 1 comma 1 over 4. So that's our vertex. So 1, not to scale, 1 over 4 is here. This is the vertex. And because UA is negative, means that the parabola will face down like this. So what is the range of this function? As you can see, the graph always go down starting from 1 over 4. Means that the range of fg will be always less than equals to 1 over 4. So 1 over 4 and go down less than. So that's our final answer.